The statements made by an engineer regarding arc fault circuit interrupters, or AFCIs, contain some truth, but don't offer a complete picture of their benefits and limitations. Firstly, it's correct that AFCIs are most sensitive to line-to-ground arcs, a major cause of electrical fires. However, their effectiveness extends to other types of arcs, including line-to-line arcs, arc faults within lights and appliances, and arcing in junction boxes and electrical enclosures. Secondly, while AFCIs provide the most protection at the receptacle where they are installed, they offer some protection beyond the receptacle in certain situations. For example, AFCIs can detect and trip on arc faults in extension cords plugged into the receptacle, flexible cords and cables downstream of the receptacle, and luminaires and other appliances connected to the same circuit. Thirdly, AFCIs don't offer significant protection against overcurrent conditions, which are typically handled by standard circuit breakers. However, AFCIs are designed to detect and trip on arc faults, which can generate heat and lead to ignition even before a significant overcurrent occurs. Fourthly, while AFCIs may not be as effective as ordinary circuit breakers in clearing dead shorts, they are very effective in detecting and tripping on intermittent arcs, which can be a major source of ignition. Sparks generated by intermittent arcs can ignite nearby materials, even if they don't produce significant heat. The idea that electrical metallic tubing wiring and redundant grounding eliminates the need for AFCIs isn't correct. While E&T wiring and grounding may offer some protection against electrical fires, they don't eliminate the need for AFCIs. AFCIs offer unique and valuable protection against arc faults, a common cause of electrical fires. Addressing each point in more detail, we can understand the reasoning behind each statement and the counter-arguments. Focusing on the first statement about line-to-ground arcs, the sensitivity of AFCIs to this type of fault is due to the typical path of the arc. A line-to-ground arc often involves a high-impedance path, limiting the current. Standard circuit breakers, which are designed to trip on overcurrent, may not detect this low-level fault current. AFCIs, however, are designed to detect the unique waveform characteristics of an arc, even at low current levels. Line-to-line arcs and arcs within appliances and enclosures can also be effectively detected by AFCIs because they still produce similar arc signatures that the AFCI is designed to recognize. Moving to the second point, protection beyond the receptacle, it's important to understand how an AFCI works within a circuit. The AFCI monitors the current flow in the circuit, looking for arc signatures. If an arc occurs in an extension cord or appliance connected to the receptacle, the AFCI will detect the arc and trip, cutting off power to the entire circuit. This protection extends to any device connected downstream of the AFCI within the same circuit. Consider a faulty lamp cord plugged into an AFCI-protected receptacle. If the cord develops an arc fault, the AFCI will trip, preventing a potential fire. Regarding the third point, protection against ignition from heat, it's critical to differentiate between overcurrent and arc faults. Overcurrent is when the current exceeds the capacity of the circuit, typically caused by too many devices plugged in or a short circuit. Standard circuit breakers protect against overcurrent by tripping when the current reaches a certain level. Arc faults, on the other hand, are unintentional arcs of electricity that can generate intense heat. These arcs can occur even when the current is below the level that would trip a standard circuit breaker. AFCIs are designed to detect these arcs and trip before the heat becomes a fire hazard. An example is a loose wire connection in a junction box. The loose connection can cause an arc, generating heat that could ignite nearby insulation or wood. An AFCI will detect this arc and trip, preventing a fire. Finally, concerning dead shorts and intermittent arcs, a dead short is a low-resistance connection between the line and neutral conductors, resulting in a very high current flow. Standard circuit breakers are very effective at clearing dead shorts because the high current causes them to trip almost instantaneously. However, intermittent arcs are more subtle and can be more dangerous. These arcs are often caused by damaged insulation or loose connections. They may not draw enough current to trip a standard circuit breaker, but they can still generate sparks and heat that can ignite nearby materials. AFCIs are designed to detect these intermittent arcs and trip before they cause a fire. A classic example is a damaged zip cord on a lamp. As the cord is moved or flexed, it can create an intermittent arc between the conductors. An AFCI will detect this arc and trip, preventing a potential fire. While EMT, electrical metallic tubing, wiring and redundant grounding improve electrical safety, they don't replace the need for AFCIs. EMT wiring provides a grounded metal enclosure for the conductors, reducing the risk of ground faults. Redundant grounding provides multiple paths for fault current to flow back to the source, improving the effectiveness of ground fault protection. However, neither of these measures protects against arc faults. Arc faults could occur within the wiring itself, even in EMT conduit. Damaged insulation, loose connections, or corrosion can all create arc faults that an AFCI would detect and trip on. AFCIs are required in many areas of the home, including bedrooms, living rooms, and dining rooms by the National Electrical Code, or NEC. The specific requirements vary depending on the addition of the NEC and local codes. But the general trend is toward increased AFCI protection in residential and commercial buildings. There are two main types of AFCIs: branch circuit AFCIs and combination AFCIs. Branch circuit AFCIs protect against parallel arcs, which are arcs between the line and neutral or ground conductors. Combination AFCIs protect against both parallel arcs and series arcs. Series arcs are arcs in a single conductor, such as a broken wire. Combination AFCIs offer more comprehensive protection and are generally recommended. When installing AFCIs, it's important to follow the manufacturer's instructions and to test the AFCI after installation to ensure that it is working properly. AFCIs have a test button that simulates an arc fault and causes the breaker to trip. Regular testing of AFCIs is recommended to ensure that they are functioning correctly. In summary, AFCIs provide an important layer of protection against electrical fires by detecting and tripping on arc faults. While EMT wiring and grounding provide other important safety measures, they do not eliminate the need for AFCIs. AFCIs are a valuable addition to any electrical system and can help to significantly reduce the risk of electrical fires. Remember to consult with a qualified electrician for any electrical work and to ensure that your electrical system meets all applicable codes and standards. Understanding the nuances of AFCI technology and its application is crucial for ensuring electrical safety in both residential and commercial settings. While standard circuit breakers offer protection against overcurrents and short circuits, AFCI specifically targets arc faults, which are a common cause of electrical fires that might otherwise go undetected. Arc faults can occur due to various factors such as damaged wiring, loose connections, or insulation breakdown, leading to unintentional electrical discharges that generate heat and potentially ignite nearby combustible materials. The ability of AFCIs to detect these arc faults and promptly interrupt the circuit is paramount in preventing electrical fires. The different types of AFCIs, namely branch circuit AFCIs and combination AFCIs, offer varying degrees of protection. Branch circuit AFCIs are designed to detect parallel arcs, which occur between the line and neutral or ground conductors. On the other hand, combination AFCIs provide enhanced protection by detecting both parallel and series arcs. Series arcs, which occur within a single conductor, can result from broken or frayed wires and pose a significant fire hazard. Combination AFCIs offer a more comprehensive solution for arc fault detection and are generally recommended for enhanced safety. The National Electrical Code, or NEC, outlines the specific requirements for AFCI protection in residential and commercial buildings. These requirements vary depending on the addition of the NEC and local codes, but generally mandate AFCI protection in various areas of the home, including bedrooms, living rooms, dining rooms, and other living spaces. By adhering to the NEC guidelines and local codes, homeowners and building owners can ensure that their electrical systems are equipped with adequate AFCI protection to mitigate the risk of electrical fires. Proper installation and testing of AFCIs are essential to ensure their effectiveness. Following the manufacturer's instructions during installation is crucial for ensuring that the AFCI is properly wired and functioning correctly. Additionally, regular testing of AFCIs using the built-in test button is recommended to verify their operational status. By pressing the test button, a simulated arc fault is generated, causing the breaker to trip if it is functioning properly. Routine testing of AFCIs helps to identify any potential issues and ensures that they are ready to provide protection in the event of an arc fault. It's important to recognize that AFCIs are not a substitute for proper wiring practices and regular maintenance of electrical systems. Adhering to established safety protocols, such as using appropriately sized conductors, properly terminating connections, and avoiding overloading circuits, is crucial for maintaining a safe electrical environment. Additionally, regular inspection of electrical wiring and components can help to identify potential issues before they escalate into hazardous situations. While AFCIs provide an additional layer of protection against arc faults, they should be considered as part of a comprehensive approach to electrical safety. The technology behind AFCIs involves sophisticated algorithms and electronic components that enable them to distinguish between normal electrical activity and arc fault conditions. AFCIs continuously monitor the current flow in the circuit and analyze the waveform characteristics to detect the unique signatures of arc faults. These signatures may include irregular current patterns, high-frequency noise, and rapid changes in current amplitude. By analyzing these characteristics, AFCIs can identify arc faults and promptly interrupt the circuit to prevent potential fires. The sensitivity of AFCIs to arc faults can be adjusted to minimize nuisance tripping, which occurs when the AFCI trips due to non-hazardous conditions. However, it's important to strike a balance between sensitivity and nuisance tripping to ensure that AFCIs provide reliable protection without causing unnecessary disruptions to electrical service. Consulting with a qualified electrician is recommended when selecting and installing AFCIs to ensure that they are properly configured for the specific electrical system and application. In conclusion, arc fault circuit interrupters, or AFCIs, are an essential component of modern electrical safety systems. By detecting and interrupting arc faults, AFCIs help to prevent electrical fires and protect lives and property. Understanding the benefits and limitations of AFCIs, as well as adhering to proper installation and testing procedures, is crucial for maximizing their effectiveness and ensuring electrical safety in residential and commercial settings. Remember to consult with a qualified electrician for any electrical work and to stay informed about the latest advancements in electrical safety technology. The ongoing development and refinement of AFCI technology continue to improve their ability to detect and respond to arc faults, making them an increasingly valuable tool in the fight against electrical fires. By staying informed and proactive, we can create safer electrical environments for ourselves and future generations.